Welcome to the PADEP video tutorial series on non-community water system approvals. In this series, we will review the various components and requirements of the new approval process for non-community water systems. This video will cover Module 3, Chemical Feed Systems Handling and Storage. Module 3 is intended for any non-community water system that is installing or modifying chemical feed systems, chemical handling, and/or chemical storage for their system. Let's look at the information needed to complete Module 3. Section A covers chemical feed systems, solution tanks, feed lines, storage, and safety. Chemical feed pumps should be capable of providing the correct dosage of the chemical at the correct rate. These pumps should also be located as close to the feed point as possible. The further away from the feed point the pumps are, it becomes increasingly difficult to ensure accurate and precise chemical dosage. All chemical feeds should have separate feed lines, pumps, and storage to avoid any unwanted reactions between chemicals. Pumps should operate at a minimum of 20% capacity to ensure proper operation. Chemical feed pumps are less accurate at the extreme low end of the operating range, and it also allows less room for adjustment. Feed rates should be proportional to the rate of flow if not synchronized with well pump operation. A proportional rate to the flow means that feed rates are set up to feed a specific amount of chemical as a proportionate amount of water passes by. This helps maintain a steady concentration in the effluent water. However, if the water pump is only operating intermittently, the chemical feed may need to be set up to only operate when the water pump is in operation, to ensure the chemical is only being fed when the system is producing water. There should be provisions to protect the equipment from freezing. This may be as simple as keeping the thermostat set at a certain temperature when the weather begins to get colder. Feed pumps and storage tanks should be ANSI NSF Standard 61 certified for the specific chemical used to ensure that they are of the proper quality to safely operate with the chemical used. All chemicals should be certified for conformance with ANSI NSF Standard 60 or food grade standards. This is to ensure the chemicals, when used in the correct manner, are safe to use in the water treatment process. Pipes supplying water for mixing or dissolving chemicals, also called makeup water, should use finished water to help ensure consistency in chemical treatment processes. Supply lines should also have an air gap to prevent back siphoning. All chemical storage should be outside of pits, as pits may become flooded. All solution tanks should be covered and able to provide 24 hours of water treatment. Uncovered tanks could lead to possible contamination, and not being able to treat for at least 24 hours is inefficient and could lead to improperly treated water delivered to consumers. Secondary containment should be provided at 110% the size of the largest chemical storage tank to ensure the containment is large enough to hold even the largest spill from the main container. It is important to note that even double-walled vessels require spill containment. Chemical feed lines should be easily accessible and protected against damage. They also must provide an adequate slope for draining purposes. Accessibility enables operators to more easily address any issues that may arise. All incompatible chemicals should be stored in separate rooms or structures. Please see the link below to access the Chemical Compatibility table. Using the table, you will be able to determine which chemicals can and cannot be stored together. Let's take a closer look at chemical compatibility. There are 6 main chemical compatibility groups: acids, bases, salts and polymers, adsorption powders, oxidizing powders, and compressed gases. In addition, there are 6 important rules about chemical storage. Do not store different compatibility groups together. For example, you should not store acids with bases because they are in different compatibility groups. Do not store liquid and dry chemicals together. Do not store cleaning products, especially ammonia-based cleaner, with water treatment chemicals. They should always be stored separately from each other and from all other chemical groups. Do not store products such as paint, antifreeze, detergent, oil, grease, fuel, or solvent in the same area as water treatment chemicals. Do store all chemicals in secure, well-ventilated areas that are free of moisture, which is especially important for dry chemicals, free of excessive heat or cold, ignition sources, and flammable or combustible materials. And water treatment chemicals need to be stored out of direct contact with sunlight. Here is the compatibility table. This chemical compatibility table uses all these rules to show which chemicals should not be stored together. Let's look at an example. You can see by using the table that hydrofluorosilicic acid, which is used for fluoride addition, should not be stored with calcium hydroxide or lime. Not only are these two chemicals from different compatibility groups, fluoride is an acid and lime is a base, but one is a liquid while the other is dry. To verify this, you can also follow the row of calcium hydroxide, row 7, until you get to the column of hydrofluorosilicic acid, column 2, and see that this block is marked with a red N. Back to the final question in section A, whenever dealing with chemicals, proper safety equipment should be used. The last section in Module 3 is to address all the no answers in the module. If any of the questions in this module were answered no, this section must be completed to explain those no answers. Enter the question number for Module 3 and then enter the explanation or justification for selecting no. Lastly, look over the module one final time for completeness before submitting. If all of the questions answered with no have been addressed, check yes here. Up next in the series is Tutorial 6, which will cover Module 4, Pumping Equipment.